Okay, so me and John are just solving one variable equations, and then these are just some tips and tricks that I came up with. So the first one is when doing a distributing problem, remember to distribute into the numbers and equations in the parentheses. And then the second one is when you're doing a subtraction and addition problem, like when you're subtracting on both sides, remember to subtract both sides. And then this is number 1. And then we're gonna start out by subtracting. And then we're gonna start by subtracting
That's a highlighter.
4.
That's a highlighter.
And then you're gonna get 8x and then equals x minus 28. Since it's a negative 4 and it's a negative 24, you have to add them together to make a negative 28. You're gonna subtract the x because you can't have x on both sides. And then you're gonna get 7x. Oh, God. Equals negative 28. And then you're gonna divide that by 7, right? Yeah. And then x equals
Top drawer.
this much?
Yeah.
Oh,
4.
I knew that.
Negative 4.
And you can rest your hand on the screen if you want to. That's how you usually write.
I know.
Okay, just make sure.
There you go. And then that's the first equation. The second equation, you only have mx on one side, so you have to subtract 1 time. You're going to subtract 9. You get 12. And then you're going to divide again. And you get 2. No. Yeah, 2. Yeah. And then for the last one, you're distributing. So, like I said in the tips and tricks, you have to remember to distribute all of the numbers inside. So you're gonna have 4x minus 12 equals 20, and then you're gonna add 12 because it's negative 12, and then on both sides. You're gonna divide again. You're gonna get 8 for your x. 8. And then these are the practice problems.
Alright, for the first step, you're gonna minus 5 on both sides. And then you're gonna rewrite it over here. 4. Alright, got that. And then you want to do a plus 2 on both sides. Okay. And then you'll get x equals 6. And then you want to rewrite it. And you go x minus 2 equals, and you're going to make it negative. So, negative 4. And you want to go plus 2 again on both sides. And then you bring it down, and you get x equals negative 2. And that's better.
Alright, our next equation here, it is first thing I'm gonna do is distribute 3 into this, so 3x minus 12 equals 2x plus 5. Add 12 on both sides. So I have 3x equals 2x plus 17. Subtract 2x on both sides. I have x equals 17. Can I?
Yeah.
Now then, for the other one, I do 3x minus 12 equals negative 2x minus 5. Add 12 on both sides. I get 3x equals negative 2x plus 7. Add 2x on both sides. I get 5x equals 7. Divide by 5 on both sides. And then I get x equals 1.4, I think. Any questions?
Yeah.
So negative 2 less than w. You would, since it's less than that, you would have to go this way. And it's open because it's not a greater than or less than kind of problem. Or greater than or equal to. And x greater than 77 z. Less than. For the next question, it's in the 2 now. And greater than 1, so you would. So you would flip the circle at 1 of you at that. Yes. The next one is r greater than 4. first one we're gonna make the equation first. So, x. So it'll be greater than that.
Okay, so we're doing solving inequalities. So we're gonna start with the first one, and this first column is an and equation. So our equation is negative 21 is less than or equal to y plus 69 is less than 29. So what you're gonna do is you're gonna subtract 69 on both sides, on all sides, and you're gonna be left with negative 90 is less than or equal to y less than negative 40. It's all you have to do for that one. Yeah. Oh, go ahead. Okay, the next one is an OR problem. So this is negative y plus 25 is less than or equal to 61, or y plus 90 is less than 15. So you're going to, for this side, you're going to subtract 25 on both sides. And you're going to be left with negative y is less than or equal to 36. And then you're going to divide by negative 1. And since you're divided by negative, you have to switch the symbol thing. Yeah. And then you're left with y is greater than or equal to negative 36. And then for the other side, you're going to subtract 90 on both sides. And you're going to be left with y is less than negative 75. Yeah. Alright, so this one's considered like the normal problem. So it's negative 10x plus 21 is greater than or equal to 69. So you're just gonna subtract 21 on both sides. Then you'll get left with 10x, or negative 10x is greater than or equal to 69. Or no. How do I erase?
To flip the pen over, it acts like an eraser on the backside.
And then you'll be left with 48. And then you're gonna divide negative 10 on both sides. And since you're dividing by a negative, you're gonna have to switch the sign, I guess. And you'll be left with x is less than or equal to so confusing. Is less than or equal to 4.8, negative 4.8. Yeah, that's it. Any questions?
Tips, tricks?
So one of the tips is you switch the symbols when you divide or multiply by a negative number. And then another one is what you did to one side, you do the other side.
Okay, so my name is Alan and she's Kate and we're doing word problems.
So first we're going to explain like what's an equation and what's an inequality. So the definition of an equation is a statement that the values of two mathematical expressions are equal and is indicated by a sign, like the equal sign. And then here's an example of how to solve it. Basically you're getting the variable and coefficient to one side and the constant on other, and then dividing it to get like what the variable is. So that's what I did there.
And the definition of an inequality is the relation between two expressions that are not equal, employing a sign such as not equal to, greater than, or less than. And here's an example. So you would just subtract it. So then your variable is either greater than, less than, or equal to the number.
So the first word problem that we're doing is an equation one. And it says, Johnny owns a melon patch. The entrance fee for one person is $5. Each melon picked is $7. 20 people visited his melon patch yesterday, and he made a total of $345. How many melons were picked yesterday? Write and solve an equation to represent how many melons were picked. Okay, so it says that the entrance fee for one person is $5. Can I change colors?
Yep. There's preset ones at the top too if you want to just click on different pens.
And each melon picked is $7. And 20 people visited, and in total he made $345. So put that into an equation. You do 7m because it's $7 per melon, plus 5 for the entrance fee, and you multiply that by the 20 in parentheses because 20 people visited and it's $5 each, and then 345 for the total that he made. So that would be your equation, and it says write and solve one. So that's written, and to solve it, you would say 7m plus 5 times 20, and 5 times 20 is 100 equals 345. Then you need to get your constant away from the 7m. So you subtract 100 on both sides of the equation. So then you're left with 7m equals 245. I'm going to move it over here. So then you divide, you divide by 7 on both sides. So you get m equals 35. And then m represents the melons. So you could say 35 melons were picked on Thursday. And that's it for the equation.
Okay. So, an inequality, so it's Todd is in a marble rolling contest. He needs to roll the marble at least 40 feet to win. He only gets 2 rolls. On his first roll, he rolled his marble 28 feet. Write and solve an inequality that represents how many more feet he needs to roll to win. So he needs at least 40 feet, and he rolled the marble 28 feet. So you would do the variable, which is how many feet he needs left. So it would be f plus 28 equals 40, and you would just subtract 28 on both sides, and oops, hold on. It'd be, yeah, so then f is greater than or equal to 12 feet. So he needs to roll 12 feet on his next roll to get it greater than or equal to 40 feet.
Okay, so for tips and tricks, we have a few. One is when you're reading the word problem, underline or highlight like the information that you're finding, and that's what we did on like the inequalities and the equation one that we just did. Another way is you plug your answer back into the equation and check your answer. So what you got for the variable, you put it back to the equation that you wrote to make sure it was right, and then just make sure you're reading like thoroughly the problem. You're reading it like nicely, not skipping any information. And that's it.
My name is Finley. I'm Olivia, and we're going to be talking about function versus relations and linear versus nonlinear. Okay. Awesome. Okay. A function is a relationship between a set of x and y values.
An x value can have different corresponding y values, but a y value can have different x values as there are the same x values and they have the same y values. It is still a function.
A relation is a set of x and y values that have x values with more than one y value.
A linear function is a function that has x and y values that have a constant rate of change.
A nonlinear function is a function that doesn't have has a constant rate of change.
So those are all the definitions that we'll be using throughout the tutorial.
Mhm.
So I guess we can start out with problem 1.
Yeah.
So we're going to be looking for we're going to figure out if it's a function or not a function. And to do that, I'm just going to list out the x values first. And then list out the y values. So it's a function because the x value, all the x values go to different y values. And to figure out if it's a linear equation, you have to look for a constant rate of change. So +1, and then all these would be +2. So it's a linear function.
Okay, now we're gonna be moving on to table. Okay, here Olivia, I'll do this one. Okay, so this one's similar. You can
Eraser. Yeah, just use that.
okay.
You don't have to spray.
Okay, this one's similar. First, you should but you know all the x values and y values are neatly already written, so we can see that two of them, without even having to write anything, we can see that there are two 2's, and each 2 has a different y value, which means that it wouldn't be a function, because remember from the definitions that if two x values are the same, they have to have the same y value. Because if they don't, then it's not a function. Okay, so the answer would be not a function. Okay. Now, oh shoot. Here, I want to say, Olivia, can you go to the go first?
Okay, so this one is a graph, and in order to figure out if it's a function, you can use the vertical line test. So the vertical line test checks if any point has the same x value, and if it does, then it's not a function. So basically what you do is you draw a line going straight down, and there's only one point on this one. So it is a function.
And basically the whole point of the vertical line test is it checks if any because like again if a value or if two values have the same x value, it's the same here. It's testing whether or not they have the same x coordinate. Like here, I'll just write it here. If a graph would have like a line like that, that wouldn't be a function because it doesn't pass the vertical line test. So it's wrong.
Okay. And then to figure out if it's linear or non-linear, the line would have to be straight for it to be linear, and if it's curved like this one, it would be non-linear.
Yes. So and it doesn't have to be diagonal either. It can be straight either way too.
So the answer to this problem would be it's a linear function.
Yeah. I'll write it. Wait. F. The linear function.
Domain and range, continuous and discrete. This is the first graph with the points that we have to figure out. And we found that this is the domain and range. With the domain, you have to find out what the x coordinates of these dots are, and then put them in the domain. And the range, you have to find the y coordinates here. And then you have to find out if it is discrete or continuous. And since it is not continuously going forever, it is discrete.
This is going to be my next equation I'm going to be answering. It is obviously The domain is all real numbers since you cannot find the domain. And then the range is x is greater than 3 because 3 less than 3. And because the range is 3. It is continuous.
And
These are the practice equations.
Yeah.
The no tips, tricks, none of them.
Favorite trick is if it does not infinitely go, it's not continuous.
Like with this one, how it kept going off the graph that you have, that means it will be continuous because it's continually going on, unless if it shows that it stops on the graph.
Okay, so my name is Dulce,
My name is Sally.
and we're going to tell you about evaluating functions. Definitions of evaluating functions are the meaning of evaluating a function is to substitute or plug in a variable with its given number or expression. A variable is an unknown value in an equation or expression. Some examples of a variable are x and y, etc. An example of a variable being used is 2 plus x equals 3. The meaning of the expression is a collection of symbols that generally express a quantity without an equal sign. The meaning of the equation is a statement that the values of two mathematical expressions are equal, indicated by the sign equal. Important terms are function input values, output values, function notation, and evaluating expressions and substitution.
Okay, so for our first problem, we have f of x equals 3x plus 6, and the given value of x is 2. So we would plug in the value of x in with x.
You can rest your hand on that, right, like regular paper.
So 3 times 2 is 6. 6 plus 6 is 12. So the answer would be f of 2 equals 12. So for the second problem, we have 3 different values for x when x equals 0, 2, and negative 1. So we would have 3 different separate equations since x equals 3 values. So we would have f of 0 equals 3 times 0 squared plus 2 times 0 plus 1. So 0 times 2 is 0 and 0 times 3 is 0. So we have 0. And then 2 times 0 is 0 plus 1, which gives us 1. So our answer would be f of 0 equals 1. So for our next problem, we would have f of 2 equals 3 times 2 squared plus 2 times 2 plus 1. 2 times 2 is 4 plus times 3 is 12 plus 2 times 2 is 4 plus 1, which gives us an equal of 17. So the answer would be f of 2 equals 17. And for our final problem is f of negative 1 equals 3 times negative 1 squared plus 2 times negative 1 plus 1. So negative 1 times negative 1 is 1 times 3 is 3. 2 times negative 1 is negative 2 plus 1 to get 2. So f of negative 1 equals 2. For our next problem, we have evaluate the functions of a given x value. So c times x equals 0.25x minus 3 when the given value of x is 10. So c times x equals 0.25 times 10 minus 3. So 0.25 times 10 is 5.5 minus 3, which is negative 4 over thirds. To get c of 10 equals negative 4 thirds.
Some tips and tricks for evaluating function. If function is something that will take an input and based on what that input is, it will produce an output. A tip, f of x is just a synonym for y is your output. F of x is read out as f of x. F is the name or label of the function and it's not a variable. Remember to use order of operations.
We did graphic lunch, and this is me and Jacob's presentation.
For the tips, for the equation, it's just y equals mx plus b. Mx is the rise over run or slope. B is the y-intercept where it intercepts on the y-axis.
Here is a tutorial problem in which is y equals 1/2 x plus 3. So step 1 is first you plant a dot on 3, which is on the y-axis, because that would be your b or your y-intercept. And step 2, you would go up 1, since it's 1/2. Go up 1, right 2, since rise over run. Step 3 would be connect the dots with a ruler. Or freehand it if you want. And that'd be your answer. So this is x equals 5, which is a pretty simple equation. Is there a ruler on this?
Yeah, on the top bar, it's kind of angled a little bit.
I see.
Yep. And then you can just use your 2 fingers to resize it and move it.
So weird. Ah. Struggling. Okay, that's good. Carry on. And that would be your line. And so the next question would be is going to be a bit harder. This is Jacob.
Right. I solved this one. Hold on. Okay. So since the y isn't by itself, you have to minus it so it goes to the other side. So handwriting is horrible. So that would be the equation, and then you just start from the +7, so it's up here. And then you just go down, and then right 5. Down 3, right 5, I think. Yeah. Cool. And then you can either go up and left if you have enough room, which I do, or you can go down and right again. And then you just line it up with the ruler. Awesome. And voila. Yeah.
And so this one's a bit, what did I do?
Just click the X. Thank you, Jacob.
So this one is going to be y equals 5x minus 2. And so I would first put a dot on -2. And then I'd go, since it's 5/1, which is 5, I would go up 5. And then I go right 1. I think I can go 1, 2, 3. Then I simply connect it. There you go. Yeah, and that's the end.
So we have writing equations of lines, and here's some tips and tricks. Your coordinates, they'll always be in x and y, and the slope will always be x, and your y-intercept will always be y. Parallel is when the slopes are the same, but the y-intercepts are different. And when it's perpendicular is when the y-intercept and slopes are different. which means they will intersect. Your answer will always be in slope-intercept form. So on to the first problem. So we already have our slope and y-intercept, so we could just easily plug it in. So it would be y, don't mind the handwriting, equals third x minus 7. And you put minus 7 because the 7 is negative.
Alright, so going on to the next problem. The line passes through 0,6 and is parallel with y equals 7x. So when it's parallel, that means it has the same slope, so it'd be y, oh jeez, don't mind that, equals, so when it passes through 0,6, that means that when it passes through, the y-intercept is 6. So it'd be 7x plus 6. Boom, already done. Alright, so when it's parallel to the line, we obviously know, same slope. So y equals 3x, and it passes through 1, so the line would be plus 1. There we go. Easy. Yep. Any questions?
Terms of linear inequalities graphing by Dylan and me.
Linear, it's linear.
Okay. Same thing. Okay. Okay. So, okay. So we have two things here. We have put them on the graph. So we see they're pretty much like already solved. That's very convenient for me. So this one, it's y is, less than or equal to 4, and the 4 would be the x. So so I can't read the numbers on here. It's kind of
It's y is
no, I know. So you put it at the 4. Can't read. What did I just do? Not for everyone. It works. It works. And then we got this other one here, and like the other one, conveniently, it's pretty much already solved. So would already in y mx plus b form. So that one would go on the graph. I know, I'm trying my best here, maybe. That one would go with the 1, just right here. I think so. No, I don't need help, Logan. I'm perfectly fine. I do that. Oh wait. Okay, I may have forgot something. That's my bad. I forgot you have the dot lines and stuff. So if as I wrote down here, if it's like with the line under, then you don't need to dot it. Wait. Yeah. Okay. And then if it's not, it doesn't have the lines. You don't need to dot it. So I did one of them wrong. I got this. So you gotta adopt this one. That's pretty much got it. Now we need to got a shade. So the blue over here.
say you want to do two different colors. So this over here would be blue and this. And blue. And then this side could be black. And then we have in here, this is, so they intersect here. So then anything in here would be in answer, so we just take 3 here, right here. 3. But it's supposed to be 2. So the answer would be in the x and y, so that would be 3. So if I can put in 4 for you voting.
Yeah.
Go shade. Okay, I'll go for the first line. Go do this one right here. What I like to do is write, y equals mx plus b first to go like a reference, and I know that this line right here is shaded upward, so it's y is greater than. Then I find another one, the y-intercept is 1, change that to +1, and the slope is 2. So this one right here, I would do the same thing as I did for the other line, and since it's shaded down, it will be like y is greater than or equal to, because it's a solid line. So less than equal to negative. X minus 2. Okay.
Hello, and welcome to the lesson on systems of linear equations. Now, child, Rin, you may be asking, what is a system of linear equations? Why, thank you for asking myself. A system of linear equations is two linear equations that intersect at one point, and that point is the solution of the linear equation. Kyle will tell you how to find that point.
So, the one, oh, man, definitely knows one. This one's really cool. One's graphic. Yeah, that's right. So, the first tutorial problem we're going to do today is going to be a graphing one. This is terrible.
Whatever, just.
This is terrible.
How about just solve the equation and make it not graphing? This is such an interesting lesson so far.
Yeah.
How intriguing.
I forgot that one was the graphic. You so I can take some turns.
Okay, well, finish.
I need a marker. Alright, that's a cool unexpected. So, on the first column, our first linear equation is y, we're end up here, y equals,
First equation is y equals 5x minus 3 and y equals negative 2x minus 4.
Alright, so I'm going to start with the top one. So right here is our y-intercept, so I'm going to put a dot right here. And my slope is a positive, so I'm going to go up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Yeah, I think you did something wrong.
1, 2, 3, 4. And I'll go over 1 right there. And I'll I put that down as negative 4. That's supposed to be negative 3, I think. So there's that one fixed. So I'm going to go up there. I'm going to try to do one more. So 1, 3, 5, 1. So right here. So I'm going to draw. Do something I can administrate it up here.
Attach to the board. Attach to the board.
Can you hold this, Ethan? You're right there. Ready? And then stretch it up. And right. Fair holder. Order. Alright. That. No problem. Let's see. And on this, we're going to do the next one. So this one will be again a negative 3. And we'll go down 2. So 1, 2 over 1. And we'll go down another one. Down 2 over 1. And we'll go up 2 on this one. Up 2 over 1. Up 2 over 1. And this will go again. Don't worry, we're almost done with this one. Oh, Ethan! They didn't hold you. What the heck? Alright, hold. Alright, now this one is going to be a one solution, and my answer is right here, the y-intercept. So my answer is 0. Alright, now we can go to the next two problems.
Well, what? As you can see, the fast, action-packed solving of graphing
Purchase uses.
systems.
Hold
So
on.
next up,
There we go.
for me,
Hey, you said I'd do the next step. Close enough.
okay. So the next two are in substitution. What you do
Wait.
is
Plus second one is 4y minus x equals 15. I just said it.
okay. What you do is you substitute part of one equation for another equation. So you got your 4y. And instead of just putting minus x, what you would do is, since here it says x equals y equals 10, you would put 4y minus y plus 10 from the top equation equals 15. 15.
Where's that?
That's 15.
Shake it. Just shake it.
Okay.
Just give it.
So, combining like terms and solving. So you get 3y minus 10 equals 15. And then isolating the variable, you would get 3y
Equals 5. Equals 5.
Oh, wait, oops, never mind. Just, may have messed up. But,
Yeah.
so now it actually happens to be a plus 10 and not a minus 10 this whole time. Which, it tricked you. It, only you, not me. So, doing the same thing, but now listen, you get 5y equals 5 and y equals 1, which then you would take x equals 1 because y equals 1,
Sorry,
and plus,
11.
and so x equals 11, and you would divide the 2 and do 11, 1 as the solution.
Alright. Next one. We'll say mine. We'll say mine or yours.
I
That's a
have a question. Is there a limited amount of time we have for each thing?
I mean, we're already 10 minutes in.
Okay, so we should probably just go skip the next two.
Actually, let's do 4 real quick. And then we'll do the 4 special solution. No, you do this. I'll do it. So, our final problem is going to be a big one. So, this one's going to be elimination. So, it is 10x minus y.
It's because you're writing over cleaning solution there, bud.
Oh.
You gotta let it dry.
Well, just start talking what elimination is.
So elimination is, I believe, and you can do either substitution or elimination. I prefer to do elimination, but you can do substitution if you think it's more easier. So what you want to do
Okay, so elimination is somehow making part of your equation. It's eliminating one variable completely from your equation in order to solve it faster. Yeah.
Alright, so because we gotta somehow do one of these eliminated, it does not matter which one. So I'm gonna multiply this top one. I'm going to multiply it by positive, just this one I have a negative, we're going to get x. And so I'm going to multiply this by 2. So I get 20x minus 2y equals 40. And this equals, the bottom line still stays the same, so it's negative 20x plus 2y equals 40. Anyway, okay. Wait. No, it's supposed to be negative. So, alright, so here's the substitute now. Wait, these two are the same, but they are simple. So this one cancels out too. The same with this one too. So get 0 equals 0, and that would equal IMS. So there's not a set amount of solutions for this specific problem. Alright, what do you get?
And in a system of linear equations, if you get infinitely many solutions, that would mean that that means both lines overlap forever.
So we're kind of hoping whoever did that
If one of your equations that you have
is in the scope and
is
stuff. I'll explain it.
Okay.
So if one of your equations, if at least one of your equations in a system is in slope-intercept form, which is, I'll put this up here, this case, y equals x plus b. That's your slope-intercept form. And if one of them is in that, it would be best to solve with substitution because you skip changing it into slope-intercept form. And another tip is that both of the equations in this system are in slope-intercept form. It would be best to solve with graphing since you only would need to look at the two equations and then graph and get the solution. Alright, and then graph to get the solution because then you have to change it over back into like this one right here is our slope-intercept form, and you can just go ahead and graph it.
So that was our perfectly paced and engaging lesson.
Yes.
That's obviously what it was. So any questions?